In Activity 5, the water cycle, students learn how the water in Earth's oceans gets continuously cycled through the environment. They first make water cycle chambers and observe evaporation, condensation, and precipitation. From this, they conclude that most of the precipitation that falls on Earth comes from and returns to the oceans. You will need the following materials from the kit. Activity Sheet 5, reclosable plastic bags, modeling clay, octagon-shaped plastic containers, and colored sugar crystals. You will also need to provide pencils, ice cubes, light sources, paper towels, pitcher, masking tape, and tap water. To prepare for Session 1, make a copy of Activity Sheet 5 for each student. Locate an area where students can leave their water cycle chambers in direct sunlight or under a lamp for at least 2 hours. Then, fill a large container or pitcher with warm tap water. Each team of 4 will need a plastic octagon container, a piece of tape, a stick of modeling clay, a pencil, some colored sugar crystals, and some tap water. Make sure to have towels on hand in case of spills. To begin Session 1, review students' understanding of the water cycle by asking, where does rain come from? Guide students to understand that rain is a form of precipitation that falls from clouds, and that clouds are made of water that has evaporated from Earth and condensed to form water droplets. When these droplets get large and heavy enough, they fall back to Earth as precipitation. Ask students what causes the water to evaporate from Earth's surface. Students may respond that the heat from the sun causes water to evaporate. Then ask what causes the water vapor in the air to condense to form clouds of water droplets. Help students to understand that colder air in the atmosphere causes the water vapor to condense. Inform the class that the water cycle is the continuous circulation of water through evaporation, condensation, and precipitation between Earth's surface and the atmosphere. Next, divide the class into teams of 4 and distribute the materials and Activity Sheet 5. Have teams label their containers with a piece of tape. Then ask students to mold the clay into the shape of a mountain about 5 centimeters high with a wide base. This shape should fit inside the closed container without touching the ceiling. Using a pencil, instruct students to carve 3 or 4 grooves into the sides of the mountain from peak to base. Then to dip the peak of the mountain into the colored sugar and place the mountain in the middle of the plastic container. Students should then pour about 2 centimeters warm water into the bottom of the container and close the lid. Finally, have the class place the chambers in direct sunlight or under a lamp. Help students compare the elements of their water cycle models to those in nature. For instance, the space inside the container contains air, which represents the Earth's atmosphere, the blanket of air that surrounds Earth. The clay mountain represents a real mountain, and the grooves in the clay represent riverbeds that carry water from the peak to the base of the mountain. Finally, inform students that the water in the water cycle model represents the ocean. Ask students, what do you think will happen to the water inside this water cycle chamber? Students should predict that the water will evaporate inside the container, then condense on the inside walls. Instruct students to record their predictions on their activity sheets. Tell students that they will check on their chambers in about an hour. To conclude Session 1, return the container of sugar crystals to the kit. To prepare for Session 2, each team of 4 will need their activity sheets, the water cycle chamber, a plastic reclosable bag, and 8 to 10 ice cubes. To begin Session 2, have students check on their water cycle chambers and ask, what has happened inside the containers? Students should notice that the containers look cloudy inside. Guide students to understand that the heat from sunlight or lamp caused the water inside the container to evaporate. When the water vapor hit the walls and ceiling of the container, it cooled slightly and condensed, forming tiny water droplets. Next, distribute a reclosable plastic bag with 8 to 10 ice cubes to each team. Instruct students to place the bags on top of their water cycle chambers. Ask students, what does the bag of ice cubes on top of your water cycle chambers represent? Students should respond that the bag of ice cubes represents colder air high in the atmosphere. Then ask, what do you think will happen inside the container now? Students should predict that adding ice to the top of the container would speed up the condensation process inside the container, making water drip from the ceiling like rain. Instruct students to record their predictions on their activity sheets. To conclude Session 2, place the chambers back in the sunlight for another hour. To prepare for Session 3, each team of 4 will need their activity sheets, water cycle chamber, and bag of ice cubes. After about an hour, have students remove the bag of melting ice cubes from the top of the container and observe what is happening inside the container. Ask students, what do the large drops on the ceiling of the container represent? Students should understand that the large drops represent raindrops that are about to fall. Instruct students to tap the top of the container lid to speed up the precipitation process. Ask what happens to the water droplets that fall on the clay mountain. Students should say that the water droplets trickle down toward the base of the mountain. Some drops end up in the grooves and flow into the pool of water at the base of the mountain, just as rivers flow downhill and empty into the ocean. Then ask students what has happened to the colored sugar crystals on the peak of your mountain. Students should have noticed that when the water dripped onto the sugar, the color crystals began to dissolve and run down the sides of the clay mountain into the water. Ask, what do the sugar crystals represent? Students should say that the dissolved sugar crystals represent minerals and salts that dissolve in runoff and are carried to the ocean. Explain to students that, like the sugar crystals, rain dissolves the minerals in soil, including salts, and flushes them into streams and rivers where they are carried into the ocean. This mineral-rich water that empties into the ocean is called runoff. As students learned in Activity 2, runoff from land contributes to the salinity of ocean water. Instruct students to complete the diagram at the bottom of the activity sheet. Then ask students what percentage of Earth's surface is covered by ocean water. Students may recall that 75% of Earth's surface is covered by water, but only about 70% of the water is ocean water. About 4% is fresh water, and 1% is the water in seas. Ask students, so where does most of the water come from that falls to Earth? Help students understand that since oceans cover most of Earth's surface, most of the precipitation that falls on Earth originates in the oceans. Finally, ask, what do you think would happen if all of Earth's ocean water were to disappear? Students should realize that the land masses of Earth would experience drought from a lack of rainfall and would be unable to support life. Without the oceans, most of planet Earth would be as lifeless as the moon. To conclude the activity, discard the clay, water, and plastic bags. Wash and dry the containers and return them to the kit. For science background, reinforcement activities, curriculum connections, and information about the Delta Science Reader, please consult your DSM Teacher's Guide.